Today, we're going to talk about NVH diagnosis. Here you go. You're going to need to do this too. You want both of those. One of them got thermal expansion valve, the other one, that little AC worksheet there. And
It says the same papers.
Oh, no, you didn't.
all right, what we have here is we're going to have a quick rundown on noise, vibration, and harshness diagnosis. And so what we're going to do to begin with when we start on trying to find noise, vibration, and harshness is basically sound, vibration, doesn't feel right, you know, this kind of thing. And some of you guys have already done some NVH work in here this semester, right?
What is that?
Noise, vibration, and harshness. That's basically what it's talking about there. And you got to entail details about the complaint. So we left the T off of that. What you hunting?
Yeah.
How come nobody's bringing a pen with them? I brought two in there because I figured some of you yo-yos. That's the last pen you'll get. Make sure that you put that somewhere where you'll know where it is, and don't put it in your box because somebody will take it. Hide it somewhere where you'll always know where that pen is and nobody else will, okay? All right, there you go. Yeah, hide it somewhere. Hide it somewhere. I don't care if you tape it under the table, but make sure that you have it. Make sure you can put your hand on a pen. Don't come without a pen. That's bad news.
Put it on something.
You up to muck right with? It irritates me. Diagnosing a noise and vibration condition starts with attempting to define the complaint as clearly as possible. You got to get good information from the customer, and whenever you have a service advisor, if you're working at a dealership that says, you know, shakes while driving or something like that, and you know they don't always tell you when it's shaking, but part of it is obtaining as many details as possible. You got your detailed description, you can proceed to the next step, which is your road test, and you should have three main objectives. One, you should use the information from the repair order to reproduce the condition. If it's doing it at 46 miles an hour going uphill and so on and so forth, you're going to find that way. The second is to try to isolate the vibration to a specific location. Where is it coming from? Left rear, right front, floor pan, wherever, engine compartment. The third is to attempt to isolate it to a specific circumstances and obvious components. Like if you how many of you guys, you remember Zach, when you did the drive shaft, when you actually put the clamps on the drive shaft and you threw it out of balance so that you could, you know, feel that drive shaft vibration? Anybody that hadn't done that needs to do it, because you'll probably recognize the drive shaft vibration now a lot better than you would have before, because now you felt one and you know what it feels like. So what we do is we make it vibrate and all that kind of stuff, so you can, and then you're going to have to know how to go back there and balance it. You'd be surprised at a tire store how many times they balance drive shafts to get rid of a vibration problem. People think there's a wheel vibration and all that. Is it engine or vehicle speed related? Does it occur when certain vehicle features such as air conditioning are operated? You know, what is it that changes it? Now once you've used the road test to narrow down the circumstances, the next step in preliminary diagnosis is to look for any obvious causes related to the circumstances. Look for like missing wheel weights. My dad used to tickle me. He would take his truck, and if he was driving his pickup truck and he started noticing a wheel vibration, you know what he'd do about it? He would take the weights off the wheels. Just take them off. A lot of times it'd just be so smooth. I mean, you know, if they got a bunch of weights on the wheels that don't need to take them off there, a lot of times they just put it up back smooth again. So you ought to check the vehicle for aftermarket equipment too. If somebody's put some stuff on there that wasn't on there to start with, a lot of times if you've got, you know, big ugly wheels or something like that, you're going to have stuff like that. If something's installed improperly, not designed to work with a vehicle, it can be a source of vibration and noise. So you need to look carefully at like bug shields, CB antennas, and running boards and roof racks. I worked on a Mustang one time where we were hearing a noise that sounded like it was coming from behind the instrument cluster. And what we did was we drove the car down the road and we determined it wasn't behind the instrument cluster, it was coming from somewhere else. And my shop foreman was with me, and he found a coat laying in the back seat, and he would hold it up in front of him trying to make this noise. And he says, it's coming from the windshield area here, and I'm not exactly sure why. Well, we take tape and put it over the chrome strips around the windshield, you know, like talking about masking tape, to see if that does away with the noise and all that. And the old guy that was driving the car was a fighter pilot from the Vietnam area, and he had somewhere he had to go, so he was going to bring the car back later. When he brought the car back later, he said, I found out what the problem was. I was driving along, I'm having my hand out the window, felt that same feeling on the tip of my finger that I was feeling on the windshield. And so he says, I moved my finger around until it was pointing right at it. When I got out and I looked down the thing, I was looking at the edge of my bug shield. And so he put some little Velcro and stuff on his bug shield and stopped that bug shield from vibrating and transmitted. The guy fixed it himself, you know. We didn't have time to finish it because he had to go. But anyway, CB antennas, running boards, and roof racks. Have you ever noticed how this radio antenna's got this spiral cut thing on the antenna? That's to keep it from whizzing in the air. Did you know that? That's basically a wind noise thing. Be sure to note the position of the crossbars on a van or an SUV and position them in the rear to see if that affects the condition. See those crossbars? Move them both to the rear. They can be a source of wind noise if they're in the forward position. So you're liable to hear something like that. Now, one thing that can save you time is to look at TSBs, because a lot of times the TSB will tell you, if you've got noise concerns that are common to that particular vehicle, and that might lead you to the cause right away. But once you've taken all these preliminary steps, you gotta have to go to the, you gotta isolate it. It's in the engine, it's in the rear end, it's in the axle, it's in the wheel, it's in the, whatever. It's no secret that sometimes you gotta have sophisticated tools. Now, I haven't bought one of these tools because it's really, really, really expensive. We don't do a whole lot of vibrations around here. A lot of the dealers have to buy these, because the manufacturer makes them buy them. A lot of times people don't realize that, but the dealer is actually forced to buy thousands of dollars worth of tools, and sometimes they'll never use. When I was working at the place over in Dothan, we had the Eagle dealership, which was like, Jeep Eagle. And they sent for the Eagle Talon, the 95 Eagle Talon was a brand new, different car. And they sent a $5,000 box of tools that was for that car. And we never ever opened that box of tools because we didn't ever need them. But they had to actually still buy them. That's why sometimes your dealer charges as much as they do for their labor. The first two tools we needed to discuss make it a lot easier to narrow it down. Some of you guys have actually used this. Remember the chassis ear? Got these clamp-on sensors and miniature microphones, and you can position them at various locations on the body. If they're all working right, there'll be 6 of them. Zane worked with me on one of these last semester, I think it was, wasn't it, Zane? Yep. Chassis ears got 6 clamp-on sensors. We've also got a wireless one out there, which I don't like. Paid more money for it than I did this one. This one's more reliable from my perspective. You can get better noise with that. Now, there's also one that's very similar to the chassis ear called an engine ear. And it basically has a different kind of probe, but a similar, using the same headset basically. And you can use it it's like an electronic stethoscope. You move the probe to different spots in the area where you suspect the vibration or noise is originating and narrow down a source. That will not work unless it's something contacting something though. If it's basically a noise like that flywheel noise you're talking about, where we're just listening up into the bell housing, you won't be able to do that with this electronic scope. Alright, so then you got an electronic vibration analyzer. This thing is very, very expensive. I have used one of these, and it's pretty doggone cool, but it takes some math to make it happen. Alright, so it can tell you the frequencies of the strongest vibrations or noises present at a particular location, at a particular vehicle or engine speed. Basically, you take the little sensor and you lay it up on your sun visor, and your sun visor, when it starts picking up the vibration, it'll basically give you the frequency of the vibration, the strongest, the second strongest, the third strongest on the screen. They've also got this big Bosch thing, that's got a bunch of stuff you can actually plug into the scan tool port, and you can lay sensors around and you can tell what it's going to do there. But it displays these frequencies over here. Now there is this little manual one right here. It's got a little dial that you turn, it runs a wire out, and when you get that wire out there, where the resonant frequency of that vibration with that little yellow tip on it, you basically have information about the frequency of vibration right there. See, so you use it, you hold it against the vibrating component, rotate the dial to extend the wire, and change the wire's resonant frequency, and then the wire, till the wire vibrates, and then you read the frequency, and that way you know what the frequency is. Now there's some other tools you need to have on hand to investigate this stuff. A dial indicator is made to use run out on tires. They actually make dial indicators to check tire run out. Like if you've got radial run out on your tires, you can have a situation like that. With the help of the road test, let's say you found the noise or vibration is vehicle speed, not engine speed related. In addition, suppose you've got a specific frequency from the electronic vehicle analyzer recorded at a specific vehicle speed. The next step is to calculate the frequency of the various rotating components at the vehicle speed. Like for example, you got to perform these calculations. You got to divide the vehicle speed by 5 to get the 5-mile-an-hour increments. And if a vehicle is going 60 miles an hour, there's 12 increments of 5 miles per hour. Now, if you need to know your circumference of your tire, all right, I'm going to go down here and I'm going to click on this link right here. See if I can go there. I actually missed it, I think. Let me see if I can get it to click on that. Anyway, it won't, on the PowerPoint thing, it ain't wanting to click on that. Go to slide. Okay, never mind. I'll have to show you that later. But the long and the short of it is, you got tire size calculators. Those are actual links. They worked when I did it in the classroom. But I mean in the office. But anyway, these tire size, like see, look at this. TireSize.com/calculator. If you go there, all you actually have to do, and I could cut and paste that in there in a minute if I decided I wanted to. You put in 255, 65, R15, it'll tell you the circumference of the tire. It'll also tell you how far it rolls, how many times in a mile it rolls. That's really important when you're looking for a very specific number for your vibration. You got to find out how many times the wheel and tire rotate per second at 5 miles an hour. You can find that on the tire and wheel chart, which is the thing I just showed you, which is a calculator. It's kind of like our conversion calculator on AllData, but it's basically like a website you just click to. Did you find it over there? Did you just go to it, or what? That website, I saw you playing with the computer over there. A ring gear with excessive runout can produce a first order vibration, and if the ring gear is not shaped right, it can produce a second order vibration. Now what's the difference between a first order and a second order vibration?
No divorce.
A first order vibration means that every time something turns, it bumps once. A second order vibration means that it bumps twice, and a third order vibration means it bumps 3 times per turn of that one component. See what I mean? So that's why your math is important. So, all right, on the rear wheel drive vehicles, in addition to the ones already covered, you can use the tire and wheel frequency to calculate the frequency of other components. You can multiply it by the axle ratio, and you can obtain the pinion shaft, prop shaft, and transmission, prop shaft being the drive shaft, and transmission output shaft frequency. See, when you come over that, see how this thing right here, you got your tire and wheel frequency, you can go by your pinion shaft, prop shaft, so on and so forth. When you find out what those frequencies are, remember, you're basically looking at your electronic frequency vibration analyzer screen to determine this is what the frequency of the vibration is. Now I got to find out what's spinning that speed. See what I mean? When you find that vibration is speed related, you might want to do these calculations. Rotating component. Like for instance, you got engine speed, your engine frequency, see that's giving you 50 hertz. Now what's 50 hertz mean? Tell me what 50 hertz means.
That's frequency. That's the noise, right? Noise, yeah, frequency.
How many, what is 1 hertz?
That's very.
1 time per second. So 50 hertz is 50 times per second. Right? All right. So some engine noises or vibrations are related to engine firing. The frequency of those noises corresponds to the number of cylinders on the power or exhaust stroke in 1 revolution, and that can be associated with the pulses created by the combustion or exhaust. So your firing frequency, number of cylinders over 2, engine frequency, 6 over 2 times 50, that's 150 hertz. See how you can find out by looking at your engine speed and go by that. You can tell by looking at the electronic vehicle analyzer screen what frequency lines up with what you're doing, and you'll kind of know which direction you need to go. When I went to the school on this thing, what the guy did was he actually there was a program he loaded on the computer, so you could basically plug your numbers in, and it would, there was a fancy piece of software he put in there that would tell you actually where to look, if the frequency was this, that, and the other. And it was kind of interesting because he would actually take one of the flywheel bolts off, one of the torque converter bolts off, and he added a bunch of washers under it that were kind of heavy, not so it would hit anything when he turned it through, but we would feel the vibration, and we actually had to go in there and use the EVA to track it down. If you've already found the engine frequency, you can find the firing frequency by deriving the total number of the engine cylinders by 2 to get the number of cylinders, and we've already been there, so on and so forth. If it's a 3,000 RPM vibration, which is the V6, the number of cylinders divided by 2 is 3. 3 times the engine frequency of 50 hertz is equal to 150 hertz, so on and so forth. Now here's the cool thing. Look at the pulleys. Now you're going to need to know the size of your pulleys. See how they're all different sizes and everything? So you got to find the accessory drive frequency, place the crankshaft pulley diameter over the accessory drive pulley diameter, use the ratio to multiply the engine frequency. The engine frequency is 50 hertz. The generator frequency will be 6 over 3 times that, or 100 hertz. See how the different, your generator is going to have a little pulley. Idler, is going to have one that's about a little bigger than that, so on and so forth. Your air conditioning compressor and your power steering pump, they're going to be almost as big as your crankshaft damper pulley. All right, so the first example is tracking down the noise there's a Chrysler Cirrus. All right, in order to repair, it describes the vibration that can be felt through the floor pan and seat. The vibration is present under a variety of engine and vehicle speeds. A preliminary road test confirms the condition and reveals the vibration is engine speed, not vehicle speed related. Now this is what the screen looks like, right? Basically you've got your, now that right there is part of the DRB3. But this right here is, see how you got average G's, you got 48, you got 30, you got 0. This is your most significant number right here. See, and you got your engine RPM that they're figuring in too, that's 1818. Alright, so the next steps to check engine accessory drive frequencies. So we need the sizes of the pulleys on the 2.5 liter engine. On that V6, the crankshaft pulley is 8 inches, the power steering pulley is 5 inches, the pulley for the AC is 4.5, and the generator pulley is 2.5 inches. Okay, so basically you got 48, 53, and 96 hertz respectively for those three pulleys. You getting that? Everybody getting that? You got it? Alright, Zane's still working on the air conditioner thing. Alright, these calculations may seem like a lot of trouble until you realize they just pinpointed the source of the vibration. You compare the reading on the EVA to the accessory drive, it's easy to see the power steering pump's the most likely cause of the vibration, and then you go there. So you put a power steering pump on it, the vibration's gone. That's actually fixing a car. Now then you got a neon high speed vibration. Track that down, we go to the repair order first, states the problem with the vibration that can be felt at higher speeds through the steering wheel and the instrument panel. Your electronic vehicle analyzer here gives us that number right there. You see there's your hertz, 34 hertz, 28 hertz, and 0 hertz is your least significant because it's going to give you 3 there on that particular tool. Alright, we divide the vehicle speed by 5 to get the 5 mile/hour increments. It's 70 divided by 5, which is 14, so we need to find the number of tire revolutions per second for each 5 mile/hour increment. To do that, we refer to a tire and wheel revolution chart like the one I told about online. The tires on the Neon are P185/65R14, so they turn at 1.23 times per second at 5 miles per hour. In the case of the Jeep Cherokee, brought in for a noise complaint, see she actually left a slide out on that. But basically what you're doing is you're taking that and you're doing the math to figure out which one of these frequencies does it line up with. Okay, so the repair order is not much help. The customer describes a moaning noise that occurs at various points both during acceleration and steady speeds. But my goodness, he's got 100 hertz right there. And the G's over there is how severe it is. To find the engine firing frequency, we take the number of cylinders, 6 divided by 2, get 3 cylinders firing or expelling exhaust gas per revolution. Multiply that times the engine frequency of 33.3 to get 99.9, and which is what we found out what the problem was. It's in the engine, right? So we can eliminate some causes such as first order imbalance in a crankshaft or other components if it's rotating engine speed. It's not likely an accessory drive component produced that frequency. That was that noisy Jeep Cherokee. Anything that affects combustion or exhaust pulses. And so now that we're going to go to the minivan, I'm just kind of blowing through this pretty quick because you guys, I don't know if you'll ever get a chance to use one of these. If you're a real mechanic, you probably will. If you're an oil changer, they're probably not going to let you do this, right? So basically, got a minivan brought in for a vibration complaint. The repair order provided some additional information. The vibration could be felt in the steering wheel and the instrument panel. Started around 65 miles an hour. One of the tires had recently been repaired. So you got 14 hertz and 1.15 G's. Pretty nasty there. And then the second vibration is that one there. The road test verifies the condition and narrows down the cause to vehicle speed. At 65 miles an hour, the frequency associated with the strongest amplitude on the EVA is 14, with a wheel tire factor of 1.11 and 13 5-mile-per-hour increments, and that corresponds to a first order tire and wheel frequency. Well, they turned out it was a tire and wheel issue. That's what your little, well, when they did this, got outside the specification of 30 thousandths of an inch for radial runout. If you got that, you're probably going to feel it. And they actually have these things here. You can see we've got a tool like this. And the one with the little wheel on it, like you've probably seen that we've got, is you can use it for that. The TSB recommends moving the tire and wheel by 2 lug positions and rechecking it. You break the tire down, you mark it where the valve stem is, and you move it, and then put it back on. We've actually fixed tires like that here. They had a vibration to them. Who was involved with that?
What was it?
Whenever we broke the tire down on that one car that was, that was vibrating, and we turned the tire 180 degrees, you were involved with that. And because Jonathan was part of it too, because he was pulling the... Quincy was, yeah, Quincy was the one, yeah. We were saying, this thing is hard to turn, so we put some soap on it, and Quincy grabbed it and just about jerked the tire machine off the floor. But anyway, but we did fix it. Did you notice after we moved the tire around and we got it to where we moved the tire 180 degrees, we basically lost our vibration, and that's what they wanted.
Did y'all ever fix Quincy's car?
Huh?
Did you ever fix Quincy's car?
Quincy's car was fixed it fixed itself while we were working on it, and I don't know what happened, but he's not having stalling problems anymore and all that. That was pretty spooky when he's, I told him he's trusted the car too much and tries to pull out in front of a tractor trailer, and then he hears wah, all this kind well, the thing quits on him in the road. Got a Dodge Dakota quad cab that was brought in because of a vibration complaint. The customer described the vibration as occurring around 65 miles an hour, said it was most noticeable in the floor pan and seats. You got 86 hertz there, which is pretty nasty there. All right, so the preliminary road test confirmed the vibration and narrowed down the cause of the vehicle speed-related problem. So you got a preliminary inspection, failed to reveal any previous obvious causes. Sometimes you got to dig, right? The frequency turned out to be 86 hertz at 65 miles an hour. Ta-da! See, she left out our left slide, so we may never know what that last one was. You know what I'm saying? But the long and the short of it is, you don't need to dig into go all the way through every single one of them. But the simple fact is, there is a way to find a vibration without saying, I don't know, right? Now, most of the vibrations that we have, when you get right down to it, most vibrations are basically going to be tire or drive shaft related anyway. But the long and the short of it is, somebody's got to find them, right? And we've actually had to, I've actually seen, like on this one, some of the Chrysler stuff. Well, there was a Jeep Cherokee one time that you would absolutely swear if you listened to it, it had an engine knock. But what somebody had done was when they changed the oil, they had pushed the canister purge solenoid down so that underneath an air conditioner line. And that canister purge valve, when it was sitting here doing its canister purging, it's mounted on rubber, but it was up against that air conditioner line, and it was going pop, 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 pop. And you just swear it was the motor knocking. You know what I mean? So we move it out from under there, and all of that's gone and everything.
I got a question.
All right.
That red truck at about 40 miles an hour, no matter what tires you got on it, it bounces.
Yeah.
It vibrates about 40. That's it. That's the only speed.
So you've already changed the tires and everything in you.
Yeah, the tires.
Yeah. Do you know you don't have a bent rim?
I didn't know, but yeah.
Maybe put them on the balancer and watch them go around.
Yeah, you got to put them on the balancer field and spin them through. And no matter where you put any tire, it feels the same too, I guess. I mean, no matter which wheel you put.
Speed, though,
Yeah.
if it was at a certain speed, it'd be bouncing all the time.
Does it
I mean,
bounce?
I've rotated.
Does it bounce faster when you go faster?
No, it's just at 40 miles an hour it bounces.
Oh, that's the only place it bounces is at 40 miles an hour?
Yeah.
Okay, and so we'll see, you need, whatever your frequency is, you can kind of sometimes feel it. Like the drive shaft thing is faster than the wheels. Remember what I'm saying? It's like a quiver. And so is this a quiver, or does it feel like it's going about the same speed as the wheels are at 40?
About the same speed as the wheel.
Same speed as the wheel is. And something, is that one four-wheel drive? Or what? And you may have something going on with that, with your, driveline components and all that.
I mean, it don't bother me none. I was just wondering.
Yeah, well, some people would be bothered by it and want it fixed. You know what I mean? So that's part of the deal on that.
I either drive slower or faster than 40.
I was driving well, that's smart, but I will tell you this, what he was saying was, is pertinent. I mean, he's thinking, I'm just gonna drive at a speed. One of the reasons is he's motivated to drive some other speed besides 40 where he doesn't feel it, is it's his truck and he's the one that's going to fix it. But if somebody else has got you working on it, 40 is what they wanna drive. You know what I mean? If it's doing it at 40, they wanna drive at 40 and all that. But, and there's, people can, that are wanting your professionalism has got to do with, I'm going to fix this where it doesn't shake or vibrate or anything. And there were a couple of times that I worked on vehicles like, there was a 95 Crown Vicky one time that I worked on it was still under warranty. And whenever it would go up a long, gentle grade, it would bite like I had an engine misfire, And and I was picking it up on the portable vehicle analyzer that we had for SPDS. And I knew there was nothing wrong with the ignition system because all that had already been gone through and I had double checked everything and all that kind of thing. So I called the hotline and I said, what can you tell me about this problem on this 95 Crown Victoria? And he's hawing around and I could tell he was hiding something. And so, I did a couple of things he talked about and I said, I'm not going to spend a lot of time and money on this car until you tell me something, because right now there's not anything that I see wrong with it. And finally I pushed him to the point to where you could almost see him break down and cry on the other end of the phone. He says, okay, we've never been able to fix any of those. And I said, really? He said, yeah, there was a Lincoln that was doing that and we changed just about everything except the hood of the car and it still did it. He said, and I said, well, this one here's that oddball. The ignition system had the EDIS and it was OBD1. So if we went to 2006 model, no, excuse me, it wasn't OBD1. We went to the 2006 model where it didn't have the EDIS module and the ignition was controlled by the PCM, you know, never felt it on one of those. And he says, well, I can't really authorize you to do that. I said, well, we could upgrade it to a 2006 with a wire harness and engine controller and all that. He wouldn't go with that. And then the guy that had the car said, well, what am I going to tell somebody? I said, well, just tell them that they make you feel a skip when you're driving up a long hill. I can't fix something that is designed into the car. They didn't know what to do with it up there either.
Is it on like when they're in overdrive or?
Yeah, I mean, when you're in a 45 miles an hour is where you're going to get a skip if it's going to happen. That's the heaviest load is on the engine. When you're in high gear, about 45, you know, crowding the throttle a little bit without letting it shift gear when the torque converter is engaged. Well, there's another one. It was an F-150 that was like a 93 model. And they used to have what they call lean cruise mode. When those F-150s would go down the road, the oxygen sensor would flatline on purpose. I mean, it was part of the deal. And but this guy told me, he says, when I'm driving down the road on this thing, and it had been to the Ford place over here in the next town, and I was over in Dothan, they brought it over there, and I put the vehicle analyzer on it, which is a big old box you put in the seat, you know, hook up between the PCM and the wire harness, and it's recording like, you know, 1,000 times a second and all that. And I'm driving along, going between Dothan and Ozark, and this thing, whenever I was letting off coming over a hill, it felt like somebody ran into the back of the truck. Boom! It just got jerk a crick in your neck. And I said, good grief. And I got to where I could play with it and get it to do it just about every time. And I noticed that what would happen was it was coming out of lean cruise mode and the EGR was doing something that was causing it. When I played it back and I uploaded it to Ford, and the guy said, we know about this, but there's not enough people complaining about it for us to come up with a fix. But he said, that's a programming issue in the engine controller. He said, I don't care what you do to that truck, you're always going to have that. And if this guy's learned how to get it to do it, you know what I'm saying? Well, the guy said, I thought something was wrong with the transmission. Well, I was talking to the hotline guy, and there was a guy standing out there in the ride-up area next to me, and he said, well, my truck's doing that too. If there's nothing wrong with it, I ain't worried about it. But, you know, because he had a truck that he had caught doing that too. It was like a 93 model with a straight six. I mean, if that particular truck with that particular setup would do that. But when it came out of lean cruise to sniff the oxygen sensors, make sure everything was still okay, if you happen to be going over a hill and the EGR was doing something just right, it'd go BAM! It just, I mean, you'd swear somebody hit you in the back end. It just felt terrible. And, but anyway, after I uploaded it to Ford, that's when he told me that he analyzed the waveform, and he goes, you won't ever get that out of that truck. You know, see that portable vehicle analyzer I used to have with the SBDS machine had it could actually keep, it was like having a scope hooked to every dadgum wire on that thing, giving you a trace, you know, a chart trace and all, and you can find out all kind of cool stuff like that. But anyway, noise and vibration and harshness is something that most people kind of wishes it would go away. Some people enjoy hunting it, like some people enjoy helping you hunt a bolt that you dropped. You know what I mean? Yeah, I had never enjoyed that particularly, you know, and I'd be over there and people want to come help, and they'd say, you know, can you come help me get this fuel line disconnected, and can you come help me find this bolt that I lost? And I was saying, I got my own work to do, you know, really. But anyway, so how did y'all do on your air?